Hi, this is Matthew Hancock, ATW's weld process engineer, with an introduction to production welding of trailers. In this segment, we're going to talk about a couple of things unique to trailer production welding to better familiarize new employees with the process. We'll touch on weld machine parameters and how to use weld wire stickout and gun angle to weld a variety of material thicknesses. Trailer building is a fast-paced environment where welders use prefabricated parts and assemblies in large fixtures to rapidly construct and weld trailers. Unlike code welding jobs, welders follow manufacturer procedures and DOT regulations without the need for passing welding certifications. Two major differences between production trailer welding and other fabrication jobs is that all of the vertical weld joints are welded downhill rather than uphill. And one set of welding parameters is often used for a wide range of material thicknesses. Why, you might ask? Because adjusting voltage and wire feed disrupts production line, increasing downtime. Typically, a single weld station handles thin trailer skins and thicker frame members using one set of parameters. And those weld parameters are typically set about 15 to 20% higher than is necessary to weld those thicker members. Excessive voltage and wire feed speed means welders must increase their travel speed to keep up. This comes with practice. Travel speed is key to weld size. The most common weld size on any ATW trailer is a 3/16 fillet, unless noted otherwise. This weld size is acceptable on material up to 1/2 inch thick. Occasionally, a 1/4 or 5/16 fillet weld is required, but any weld over 5/16 must be made with 2 or more stringer beads. Do not weave in a large single bead. With higher weld voltage and wire speed settings, it's necessary for production welders to keep their travel speed up to avoid creating oversized welds. An oversized weld does not equal a stronger weld. It's just a waste of time, wire, and shielding gas. Contact tip to work distance, or stick out, is the distance between the contact tip and where the wire electrode burns off at the puddle. This graphic is a representation of how an increase or decrease in electrode stick out affects the weld on a groove joint. Notice how the weld from the left to right changes with increased stick out. You can see a change in the penetration as well. Welders at ATW generally weld every trailer component at 1 or 2 settings because constantly adjusting your machine is disruptive to the production line, increasing downtime. Welders learn how to manipulate stick out, gun angle, and travel speed to weld various thicknesses on one setting. Stick out can range anywhere from 3/8 of an inch up to 1 1/4 inches or more. It really depends on where you lose your shielding gas coverage. The effect of increasing stick out is added resistance, a reduction of arc force or penetrating force, and heat. Think of it like turning down the voltage without adjusting your machine. Here you see a rough depiction of how to increase stick out for thinner material. The maximum amount of stick out you can use is limited only by your ability to maintain shielding gas coverage. Along with stick out, increasing the push angle is an effective way of managing high voltage on thin material. Simply shifting from a nearly perpendicular angle to roughly 25 degrees off the base metal will redirect the force and penetrating power of the arc. Using increased stick out and a very shallow gun angle together makes it possible to weld thin sheet metal without reducing your voltage and wire speed. Look closely at the effect of the arc plume on the contour of the puddle. More angle and stick out equals less penetrating force. The final tool to control welding temperature on light gauge metal is oscillation or whipping. While it has been statistically determined that weaves and whips increase the probability of errors, contamination, and bad fusion without bringing any benefit to the welding process, this is especially true for downhill vertical welding. However, a slight whipping action can help to intermittently freeze a molten weld puddle on the thin material, which can help keep the welder from burning through. Just remember to keep your movement small and don't whip on downhill structural frame welds. Whenever either of your workpieces are thicker than 1/8 inch, whipping or weaving of the downhill weld puddle is not permitted. Whipping and weaving while welding downhill structural welds results in intermittent lack of fusion at the root, lack of fusion along the weld leg. While 100% fusion is possible when weaving on light gauge metals, it is not guaranteed for thicker materials. Stringer beads only. Use a straight pull downhill to get a maximum weld interface fusion. As a welder new to the ATW family of trailer brands, you will receive additional hands-on training and testing to help provide you with the tools to better equip you for success. We have a few more short videos to go with your onboarding training, including fillet weld sizing, horizontal and overhead welding tips, hanger welding fundamentals, and most importantly, vertical downhill welding.